Hi, Timothy Unger here, and in this video I want to talk about some of the trig functions available in Python. So let's get started. All right, the first thing I'm going to do is import the math module. So I just type import math, and that will allow me to use some of these functions. So after that, I'm going to create a variable. I'm going to call it pi, and I'm going to set it equal to math.pi. So what this is doing is it's setting the variable pi equal to the mathematical constant pi. Okay. All right. After that, we're going to use some of these math functions. So one of the functions that I can use is the sine function. Okay, sine stands for opposite over hypotenuse. And what we can do is we can find the sine of a value if we give the value in radians. So I can say math.sine, and then I can pass in the value in radians. And I'm going to do pi fourths, which is equal to 45 degrees. Okay, so we're going to do print math.sine of pi fourths. Okay, let's save this and let's open up a terminal. And I'm going to cd into Python here. And what I'm going to do is run this program with Python 3 and then the name of the program, which is trig.py. Okay, and so we get this value 0.707 106,781,865, so on and so forth, which is equal to the square root of 2 over 2. So that's the value of the sine value of pi fourths. We can also find the cosine value of pi fourths, which is going to be the same exact value in quadrant 1. All right, so let's run this with Python 3 and then the name of the file, trig.py, and we see we get the same value for both there. Okay, so that's pretty neat. All right. We can also do the tangent value, so I can do math.tan of pi fourths. And in this case, the tangent value of 45 degrees or pi fourths radians is equal to 1, but Python's going to approximate it, so it's not going to print out exactly 1. And as you see, we print out 0.9 repeating, but that's because of the Python approximation. If I wanted these to differ a little bit, I could move them to quadrant 2, so I can do 3 times pi fourths here, and that'll give me 3 pi fourths, which is 135 degrees, and that's in quadrant 2. Now for this, in this particular case, the cosine value, the second value that's going to print out is going to be negative because the cosine is equal to the adjacent side of the hypotenuse. The adjacent side in quadrant 2 is negative because the x values are negative. The sine is the opposite over the hypotenuse, so the sine is still positive because we're still dealing with positive y values. Because we're dealing with 45-degree triangles, these values, the absolute value of the values is going to be the same because the sides are the same opposite the 45-degree angles. Okay, let's run this and we'll see the first value is positive, second value is negative, and we still get that 0.9 repeating for the tangent. Okay, so first value positive, second value negative. Very good. All right, we can also do inverse sine, inverse cosine, and inverse tangent. And those are arcsine, arccosine, and arctangent. And the way we can do that, what that happens is if we put in the value that outputs from the sine value, so let's say the sine value outputs 0.707, meaning that the actual angle was 45 degrees or pi fourth radians. If we put 0.707 into an arcsine, we're going to get back the original angle value in radians, which is going to be pi fourth radians. Okay, so let's print math, and we do a sine for arcsine, and we're going to do 0.707 and close this out. And we should get 0.7853, I believe. Okay, so let's run a terminal here, and let's rerun it, and we get 0.7852, which is very close to what pi fourths is. So let's just show that by let's print out pi fourths, okay? And if we were in a terminal here, so for pi fourths, we get 0.7853, etc. For the arcsine of 0.707, we got 0.7852. Now, the reason being is if you look up here at the original values here, we got 0.707, then this 106, all this stuff extra. I just did 0.707. So if I did all of this, we should get the same values, all right? We can also do, let's get rid of this. And we can also do arccosine, so arccos, 0.707. Okay, and when we do that, we should get also 0.785. Now we're getting a slightly different value. Now if we had 0.707 with the 106 and all the extras, we would get the same exact value. But the whole point is we're putting in basically 0.707 square root of 2 over 2, and we're getting back pi fourth radians. Okay. All right. We can also do arctangent. So if we do 1 here, we should get back now we should get back the exact value of pi fourth radians. All right, so let's run that. And okay, so the next one, the 0.7853 is the exact value of pi fourth radians, at least approximated to Python to however many decimal places are there. But all right, so last two things I want to talk about are switching from radians to degrees and then from degrees to radians. So what I can do is print and do math.degrees, and then if I pass into here pi fourths, I should get back 45. So let's run this, and you see I get 45.0, okay? Likewise, if I print math.radians and I put in 45 here, I'm going to get back this 0.7853, etc., okay, which is pi fourth radians, the exact value of it. Okay, and I get for that last value 0.7853, etc. Okay, so I hope you found this video interesting on some of the trig functions you can use. We covered sine, cosine, and tangent, arcsine, arccosine, and arctangent, along with switching from radians to degrees and degrees to radians. If you did find it interesting, please give this video a like, as it really does help get the video out to more people. I also want to thank you for watching and hope to see you in the next one.